Hello everyone, welcome to Twins Talk. This is the second round of my comparison video of the Raise3D E2 and the Stratasys F170, and this time we're going to print ABS and see which of these printers perform better. So stay tuned and find out more here at Twins Talk. As you can see, these are the printed parts. This one is from the Stratasys printer and this is from the Raise printer. But before we can compare these two, I will just show you my slicing settings. So we'll head over to the desktop PC and see what I have been using for these two prints. I've started GrabCAD print and loaded the STL file in. As you can see, it's a basket for a kick scooter. When I was searching for something to print, I stumbled across this one. It should be difficult because it has a low wall thickness and it's big enough to fit onto the print plate. And as you know, when printing ABS, temperature difference is a problem. So the Stratasys printer does have a heated chamber, whereas the Raise3D E2 has a heated bed. So what will happen most likely is that the ABS will start to curl on the edges because the heat difference from the bed up to where it is printing will give it some stress, and the edges will most likely start to peel off at the bottom. So I will just show you what slicing settings I have here in GrabCAD Print. If we look at the tray settings, we can see that I have a slicing height of 0.254 millimeters, and we have a part build style normal. The infill is at around 75%. That is where you have this sparse high density infill. And the support, I choose smart and to use model material to just print faster, so the head doesn't have to switch back and forth between the two materials, the support material and the model material. I also changed the self-supporting angle to 35 degrees because these points here do have an angle, as you can see, and I do not want it to have support in there. So that's actually everything I've chosen here. It's simple in GrabCAD, you don't have much of an option. And if we look at the sliced part, you can see we have the wipe tower here, and then we have the raft on the bottom. And I'm going to just slice this, and as you can see, I have the support structure here on the top, and I'm using model material for support. And going down, actually you can see the infill. Let's see. This is the infill around 75%, and I will show you later on what I've been using on inside. So I tried to copy the slicing settings of GrabCAD and did my own idea maker profile so it matches up what we see in here. That's actually everything here in GrabCAD Print I can talk about. I will go over to idea maker and show you what's in there. Here's the file in idea maker, and I already sliced it, but I will just show you the settings I have here. This is my sparse high density profile, and the layer height is the same, 0.254 millimeters. We have 75% infill, we have 2 shells, and the speed is just the normal speed you have. And as you can see, just start the slice again. We don't want to have any raft. I will tell you why. I was printing this a few times, and because of the problem I had with adhesion to the support material at the bottom, I opted for not using the raft. I will show you the parts, and to get this print done I had to tweak the printer really well, so I will just show you my settings here. As you can see, this will take around 32 hours. I have a heated bed with 100 degrees Celsius. The material is being extruded with 255 degrees Celsius, the ABS material. And for support I'm using here the support material from the Stratasys printer. And if I just go down, you can see it's just the same in structure. The blue one is the support material. There is something strange about this slicing settings. So I will just get this right and come back again. So I'm back again here. As you can see, I just changed the profile. The infill density was at 80%, the shells were at 1.5%, 1.5 shells. So let's see. This is the preview, and if I go down, you can see that my left extruder is the model material and the right extruder is the support material. So this white thingy here is my model material, and if we go down here like so, just to compare the infill densities, you can see that this is nearly the same with 80% what we have on the Stratasys printer. But as you can see here, this will take 35 hours to print, whereas the let's say the Stratasys printer will take around 10 to 11 hours to print. So it is much faster, 3 times as fast, but we will see how the parts will turn out. Back at the parts, and I will just show you what the printers did, but I have to say that this was really difficult to print. It was not difficult, it was a one-time shot for the Stratasys one, but Raise had a really big problem to print this file right. I was using a raft at first, and I will just show you what it does look like, or it did look like. And these are my failed prints, and as you can see, I'll try to focus on here. I just first printed the raft and started printing with my model material, and after the first layer it actually clogged. So my nozzle clogged. This was due to my 2 nozzles not being calibrated. So I started calibrating my nozzles, and the distance was right. I started to print and it clogged again. So I don't know why this happened, and I really didn't want to try it out anymore, so I just started printing without the raft, and it failed. As you can see, this one just failed after, let's say, 10 or so or 20 slices, and I will show you these with my gimbal. Looking at this, you can see it was printed this way, and it started to lift on these corners here. So bed adhesion was really bad here, these corners, and this actually lead to the failed print here, and this is due to not having a heated chamber. So what to do when you don't have good adhesion? You just apply some glue, and this is what I've been doing here. So this is the print which worked out on the Raise, and as you can see at the bottom, I've just put on some glue with a glue stick, and it printed fine after that, and the print actually looks nice. Layers are consistent. Let's see if I can get the focus here. Like this, yes. And looking at the sides, we can see that there is some ringing. Get it into the light, like so. And as you can see, when I shift this, there's some ringing at the corners here. And but all in all, it's okay. I had to change the filament at some point because my first spool just ran out, and this is actually the second spool here up here, but it just looks okay. Looking at the bottom, you can see that it really lifted on the corners. Let's see if I can focus. We have some lifted up corners here. So still the glue was not enough to have this part fixed or adhere enough to the build plate, and this is on all four corners here. As you can see, this is different for the Stratasys one, and this was actually just one-shot print at the Stratasys. I just loaded the file, and as you can see, it just has a really smooth surface here. No ringing on these surfaces. Also here, everything just looks perfect. Just going to do it like this. A little bit of ringing here, but all in all, just a great print. And the top just looks great, whereas on the Raise one, the top is a little bit rough on the surface, as you can see. So I will just get this one off from the platform, and we will see how it will just look at the bottom, and then we will measure the parts at some spots and see which one is better in regards of dimensional accuracy. So let's see. Let's start with the Stratasys. I will get all of this off. All the failed print stuff. Oh, I forgot to show you this one. This was actually one with the raft that didn't work. It just curled up so much here on the corners that it was blocking the nozzle from printing, and the wipe tower just was knocked off. And after seeing this, I just didn't use the raft anymore and printed directly to the surface, to the build plate with some adhesive, with some glue on it. So this was one of the failed prints. Let's see how this will go off. We have the plate here. It's just easy to get this things off here. That's it. And we have the support material here. I will just pull on these edges. And it just comes off easy. Easy, like so. That's it. And then we have the model material as support structure in here. I will try to get this out. By just twisting. Okay. There's something strange. I will show you this with my gimbal. And if you look into the basket here, I will just try to get a sweet spot here. The camera. See? As you can see, we have the model material in there, the support material. I will try to remove that later on. But as you can see, there's some layers which didn't adhere at the bottom of this. I don't think I will get this into the camera, right? Let's see. Maybe I can just, yeah, like this. So. Here. There are some layer lines in there which I just shrinks. They didn't adhere completely to the surface on that side. So I would have to add support structure on there. Maybe that 35 degrees I had was too much. So, but all in all, it just looks great here. Now, let's get the Stratasys, the race part out of the platform. Yeah, it's just comes off easy like this, and oh, nice. And as you can see, all of my support structures are now on the build plate, and also the support which was in the basket. So I can just get it on the side and we will look at the part. And oh, we have stringing all over, and this is maybe due to the temperature I've been choosing. I will just show you this. Well, I've been printing at 255, and let's see if we can see this. Like so. And we have stringing in here all over the place. Yeah. The bottom where the support structure was is fine. There's a little bit of loose strings, maybe, no imperfections. It's a rough surface because of the support structure we had in there, but it looks okay. But the temperature wasn't right here. 255 was too high for this ABS material. It just strings, have all these strings in there, all these small little hairs. Okay, we also have it here on that side here along the lines. But as you can see, I will just try to show you that the bottom is not even. We have the gaps on the corners. I will try to see, we have the lifted corners, and it's not even. Whereas if I get the Stratasys part, it's just flush, really flush. It's perfect actually. And the only thing which was not right with this Stratasys part is the bottom in here, where the support structure I have to get out, and also the not adhering strings and lines in here. So just small comparison again, two of these side by side, and as you can see, when this will focus, the Stratasys one just looks much better, much better than the Raise one. It's more consistent, and surface is just great, as you can see. Stratasys one here, and that's the Raise one here. Okay. So let's check the dimensional accuracy. Where's my caliper? Just a second, I will get my stuff. So let's measure these, and I will measure the width of these clips here, and then I will also measure the wall thickness, and let's see which printer is consistent in dimension. I will just start with the Raise3D, and this should be 15, it's 15.2, and it's 15.17 on the left one, and the Stratasys we have 15.07 and 15.06, so they're both exactly the same. And the wall thickness on the Stratasys part is 2.4, 2.5, 2.5, actually great. This is great. Dimensional accuracy is fantastic. Let's see. We have 2.6, 2.6, 2.6, 2.54. So this is okay, but it is not as good as what we have with the Stratasys printer. So dimensional accuracy, the Stratasys printer wins on this. So actually I'm finished with all of this, and I will just sum all up and tell you what I think about this print. Let's sum this all up. As you can see, I had some failed prints, many failed prints when trying to print this part on the Raise3D printer. First, I had my extrusion problems, where my extruders didn't have been calibrated, haven't been calibrated right. So I calibrated my nozzles, and after calibrating it, I started a print, and the corners just started lifting off, and I got a failed print again. So I just got rid of the base of the raft and printed it directly onto the bed by using an adhesive, a glue stick. And despite using the glue, the corners lifted off again. So I would say the Raise3D printer just failed this part. And the layer lines are okay, we don't have any inconsistency here. but the surface on the top is rough, and dimensional accuracy is not as good as what we have with the Stratasys printer. The Stratasys printer does have a closed loop drive system, so it does know where it's going and where it is, whereas we have only stepper motors in the Raise3D, so that's the reason why the Stratasys printer is better in dimensional accuracy here for ABS. Looking at the part from the Stratasys printer, I have to say this is nearly perfect. The surface is so great, it's so shiny. I don't know if you can see this. Let's say if I can focus on here and show you what this looks like. And if I just turn it like this, do you see? It's just shiny on the surface. It's really, really nice. Where we have a lot more of a matte finish on this one, and it has a rough surface. Yes. So the Stratasys printer does have a better accuracy. It prints big parts from ABS, thin walls, high parts without any problems because of the heated oven we have in there. So for a $20,000 printer, yes, Stratasys can print ABS, and it can print it really, really well. So if you want to have repeatable part accuracy with ABS prints, you should go for a printer which just has a heated oven. Without that, most likely you will come up with parts like this, where the corners just lift off, and you may have difficulties getting the parts right over and over again. So that's it actually for today. The Stratasys printer wins in all regards when printing ABS. If you like my channel, just push the subscribe button. I will do some more tests on other materials, hopefully. And I have so many other projects to go on. Just stay tuned and find out more here at Twins Talk. See you soon in the next episode.